Good morning, dear students. We had completed with the first lesson. I hope you have completed the numericals. I had solved the doubts that you had asked me earlier. So today we shall begin with the next lesson, that is work, energy and power. So we start with the first topic, work. What do you mean by work? What is work? When you study, it is a work. When your father works in the office, it is a work. When a colleague carries a load and walks on the platform, he does certain amount of work. When you push any object, it is a work. But in physics, you are studying, it means you are not doing any sort of work. Physics has got a different definition for work. Work is said to be done when a force is applied on an object and it displaces the object in its own direction. Okay? Work is said to be done when a force is applied on an object and it displaces the object in its own direction. Then only the work is said to be done. Like for example, if I am exerting certain amount of force, I am exerting force on the board and I am not able to displace the board, then I am not doing any sort of work. Work is done only when a force is applied and the body starts to move. Like for example, if I got this box, I got this remote on my hand and I am exerting force and it doesn't get displaced, it means no work is done. If I exert the force and it starts moving, it covers a certain amount of distance, then work is said to be done. Okay. So what is required in doing work? For doing work, we need two things. Work requires force, and the second thing is displacement. Okay. So work is dependent upon force and work is also dependent upon the displacement. So again I am giving you an example. There is a car and you start pushing the car. You keep on exerting force over the car, but you are not able to slightly also move the car. Then the car remains at its own position. Displacement is zero. So work done by you is equal to zero. If you are able to displace the car to a certain distance, then only work is said to be done. Is it clear? So the work is dependent upon two factors. One, the force. Second, the displacement. Okay. So we know that work is dependent upon two factors. One, the force. The second, the displacement. Now let us take two forces, F1 and F2. They displace an object to a certain displacement only. The displacement is same for both the objects, but the forces exerted over them are F1 and F2. And if F1 is greater than F2, if F1 is greater than F2 and they displace an object by x, the displacement is x, then in that case work done by F1 will be greater than the work done by F2. Clear? Now second case, this is the first case. Second case, what we do? We take constant force F and it displaces one object to x1 displacement and another object to x2 displacement. Then if x1 is greater than x2, in that case the work done is greater in the case when a force displaces an object by x1. Displacement is for a constant force. If displacement is more, work done is more. If the displacement is same, force is more, then work done is more. So it tells you that work depends upon both force and displacement. So amount of work done depends upon the magnitude of the force applied and the magnitude of the displacement made by the object when the force is applied in its own direction. Let us consider a box that is being placed over a horizontal surface. There is a force that is applied at the point A it displaces the box to a distance b. The point of application of the force is at A and it displaces the object to the point B. The amount of work done depends upon the force F and the displacement S. So work done is the product of the force that is applied and the displacement of the point of application of the force. So it moves from the point A to point B, that is S. Work done is equal to F into S. Work is a scalar quantity. What is work? Work is a scalar quantity. This is the first thing. It is a scalar quantity. Although force is a vector quantity, displacement is also a vector quantity. The product is a scalar quantity. Second thing, when we are talking about this force is a constant force. Force is constant. A constant force is being applied. The force is not variable. The distance is changing, but the force value remains the same. Is it clear? So, work done. Now, here you can see the second important point that is to be seen here, that the object is getting displaced in the direction of the force applied. In whatever direction the force is applied, in the same direction the object is getting displaced. Is it clear? We can have another case where the direction of the force applied and the displacement are different. The direction is different and the displacement, direction of the force is different and the displacement is also different. Then in that case, we will take the force either in the direction of the displacement or we will take the displacement in the direction of the force applied. And the product of the component of the force in the direction of the displacement and the force is known as work. We have an example here. The object is placed along the slope AC and the force is horizontal along AB. Okay. Now you can see the displacement, the direction of the displacement is along AC and the direction of the force is along AB. So they are in two different directions. That displacement is not taking place in the direction of the force applied. So what we will do? We can find out the displacement in the direction of the displacement in the direction of the force applied. Okay. So we have the displacement here. Displacement is along AC. But you want, and the direction of the force is along AB. So you want the displacement along AB. So along AB, this body has reached up to this point. So what is the displacement here? This is S cos theta. You all know, you have all studied trigonometry in 9th class. Cos theta is base upon hypotenuse. So base theta, this is base and hypotenuse. This is S cos theta. Now you can see the force and the displacement are in the same direction. Therefore, the work done is equal to F into S cos theta. This is equal to F S cos theta. Now what we have done? We have taken the displacement in the direction of the force that is applied. In the second case, what we will do? We can again resolve this. We can take the component of the force. We can take the component of the force in the direction of the displacement. So direction of the displacement is AC. We produce this line here. What is this angle? This angle is theta, vertically opposite angle. This is theta. Now we drop a perpendicular here. Okay, this is perpendicular. Now F, we will take the component of this complete force in the direction of the displacement here. So we need to find out this force. What is this force? Base upon hypotenuse. So this is F cos theta. Okay. In the second case, what are we doing? We are taking the component of the force in the direction of the displacement. So direct component of force is F cos theta. Work done is equal to F cos theta into S. It is again F S cos theta. Is it clear? Now, whether there are two conditions here now. One, this one, second one here. In the first condition, we have taken the displacement in the direction of the force applied. In the second condition, we have taken the component of the force in the direction of the displacement. But for the work, we are getting the same formula, W equal to Fs cos theta. What is theta here? Theta is the angle between F and S. What is theta? Theta is the angle between F and S. Now F is a vector quantity. F is vector quantity. S is also vector quantity. W equal to F dot S. Okay, this is the dot product of two vectors, F dot S, which is equal to Fs cos theta, and work is a scalar quantity. Okay, I hope it's clear. So work done equal to Fs cos theta. It depends upon force, it depends upon displacement, also depends upon the angle between the force and the displacement. Now theta, it depends upon theta, so we can have some special cases. Theta equal to 0. What does it mean? That the force and the displacement are in the same direction. We have an object here, the force is in this direction and the displacement is also in this direction. So the angle theta here is equal to 0. The body is moving in the same direction. Okay. So in that case, cos theta, cos 0 equal to 1, W equal to Fs. This is maximum. Okay, work is done. This is positive work. Work is positive. Another example, you drop a ball. You drop a ball, the ball comes down due to its own weight, mg. This is force. And it covers a certain distance, h. So work done is equal to force into displacement, s. It is mgh. Okay, this is again in the same direction because cos 0 equal to 1. Second case, second case theta equal to 90 degree. So cos 90 is 0. Now this is a very important case. We have a person, a coolie carrying a load over his head, and he starts walking on the platform. Does he do any amount of work? Does he work? We have a coolie. I have a coolie here. He carries a certain amount of load, weight, W, and he moves in this direction. So weight is acting in this direction. The angle between the displacement and the force is 90 degree. The angle between the force and the displacement is 90 degree. Now work done equal to Fs cos 90, and cos 90 is 0. So W is 0. It means that the coolie, when he carries a load over his head, does no work. Or when you are walking, you are not doing any work against the gravity. Very important. Against gravity, the work done is 0. Is it clear? Against the gravity, work done is 0 because the weight always acts perpendicularly downward and you are moving horizontally. The angle between the two, force and the displacement, is 90 degree. Another example is of, we have the sun at the center and the earth revolving around the sun in a circular orbit. So, is the earth doing any amount of work? Answer is no. The reason, when the earth is revolving in a circular orbit, its direction at any point is tangential. Displacement, if it is left free, it will go tangentially. And the force is centripetal. From the tangent normal theorem, the angle between the tangent and the normal is 90 degree. So cos 90 is 0. Cos 90 is 0. Therefore, work done is 0. Similarly, in the case of the atom, when the electrons are revolving around the nucleus, again the force is centripetal force acting towards the center and the displacement perpendicular. So work done is 0. The rest we will continue in the next video.